Hi, I'm Hans van der Vorst and welcome to this introduction of ARTIS, that is the Availability and Reliability Tracking Information System developed by Securos. ARTIS can be used to model and optimize continuous production systems, and it has already been used successfully to optimize large-scale LNG export projects. Version 2.1 had been released on the 22nd of December 2014. Today I'll show you a small example of an oil and gas project. We are going to do four things. First, we'll have a look at the availability model. Then we'll upload some downtime events from a database and make a run. And finally, we'll review some of the results. The availability diagram is shown at the top left of the screen. The upstream produces oil and associated gas and water. The midstream processes these three product streams for export. The upstream has three fields. Each field has wells and separation facilities. The wells are grouped in zones, and each zone has 10 wells. The upstream has 120 wells in total. The separation facilities comprise of 5 trains, and each train has a high pressure, a medium pressure and a low pressure separator. The midstream has facilities for processing the associated gas, the oil and the water. The associated gas facilities have 2 trains, and each train has a gas turbine that drives a 3-stage compressor. Each equipment item is characterized by a set of capacity and downtime assumptions. The list of units is shown below the diagram. For example, the wells have unplanned reservoir management downtime with exponential lifetime and downtime distribution, a mean lifetime of 1/5 year and a mean downtime of 10 days. Now we are ready to upload some planned downtime events from our maintenance management database. Let's take Train 1 gas turbine as an example. Its event list is currently empty. We fill in the data upload form. It's an Oracle database and the database strings have already been completed. And upon completion of the upload, we see that we have 2 events now, one hot gas path inspection and one major inspection on the gas turbine. From the model, we can do a search to trace back where the events came from directly into the database. We have to log in. And here we have a view on the Oracle database with the hot gas path inspection and the major inspection. So now we log out again and go back to the model. There are some downtime events on the other equipment items as well. The availability diagram shows the equipment items that are currently down with a red background. In this example, those are the high pressure separators in field 1. That's because of a common mode failure. There is CO2 corrosion. Hence there is a simultaneous unplanned downtime. We are now ready to run the model. And for that we will choose the current quarter, the third quarter of 2015. Before submitting the run, ARTIS does some data quality checks, and upon submission the model is sent to the ARTIS server. The server application computes the availability results, organizes them in a website, and returns this in compressed form for downloading. All communications use a secure TLS 1.2 protocol, and no data is left behind on the server. So now we open the results website. The first page of the results website shows the results at the system level. That is for the whole model, and the other pages show the results for the various parts of the model, following the same hierarchy as the model itself. The first two charts show the losses, integrated over time and as a function of time, respectively. The losses that are due to capacity swings are colored red. The losses that are due to planned downtime are colored purple, and the losses due to unplanned downtime are colored blue. The capacities and losses are given in million standard cubic feet per day. The first chart has the capacity on the vertical scale and the probability, that is the fraction of time, on the horizontal scale. The surface area of the white patch equals the effective capacity. The surface areas of the colored patches equal the respective losses. Hence it's immediately clear which kind of losses dominate. The capacity losses arise from the effects of the ambient temperature on the gas turbine. The second chart has the capacity on the vertical scale as well, and time in days on the horizontal scale. It shows the daily effective capacity and the daily losses as the colored bars. The table below the top charts shows the criticality ranking, with the expected capacity, the planned and unplanned losses, and the availability and reliability. The first pie chart shows the breakdown of the planned losses, and the second pie chart shows the breakdown of the unplanned losses. From the criticality ranking table, we see that the Q3 system availability is only 81.8%. And from the pie charts, it's clear that the upstream and midstream cause planned and unplanned losses at the system level, so we will drill down on both. The results for the upstream availability is only 77.9%, which is compensated somewhat by the higher capacity, because there are 120 wells. The upstream has only unplanned losses, and most are coming from field 1. Here is field 1, and we can see that the separation facilities are causing them, and that is because of the common mode failure with the CO2 corrosion. The midstream availability is 91.1%. That is mostly from the hot gas path inspection on the Train 1 gas turbine, and there is some unplanned downtime on the associated gas facilities as well. This concludes the live demo. In summary, in comparison with other tools, ARTIS has 10 strong and unique advantages. It has a clean and hierarchical user interface that is easily accessible by a wide audience, with a low learning curve that does not require any specialist tool expertise, offering full transparency for management and all disciplines. It has a single focus on production availability, supported by a clear and consistent set of definitions, in line with ISO standards. It has a mathematical engine for accurate and fast results, even with very large models, free of random noise. A single model serves to do runs on all time periods. The past for tracking and reporting, the current time with the results conditioned on the presently known state, and the future for the common RAM-type project development support studies. It has web-based reporting with a full model hierarchy, criticality rankings, and automatically generated plots for reporting. It has light and flexible database interfaces using open source components with single-click search from the model directly into the databases, including Oracle, MySQL, SQLite, and others. It facilitates integration between the upstream and downstream, and importantly, for handover from project development to operations. There is zero IT overhead. The user interface runs in the web browsers, and there is no installation on the client's devices at all. There is full scalability and automatic load balancing of the cloud service for simultaneous runs. For future compatibility, there are upgrades to later ARTIS versions, ARTIS Cloud Service Application updates, and of course, taking full advantage of future browser updates. From the Secuos website, you can try out the ARTIS demo model yourself. The model can be accessed through secuos.com, and if you have questions or like to make a comment, you can send an email to info@secuos.com. The ARTIS manual is online, and the DokuWiki is given here as well. That's the end. I wish you have good fun. Thank you for your interest.